So just now I came across a very interesting, neat project called Felcraft, which is a fabric mod for Minecraft. And this mod integrates with the Fel AI API to bring 3D model generation directly into the Minecraft game. So it exposes a generate command where you can generate a certain object of a certain size given a certain text prompt. And I was interested to see how it works, especially since they also have a so-called stream mode where you can kind of see a live preview of the generation as it's happening. So I took a dive into what they are actually doing, and it's basically a combination of two model APIs that the mod calls on FelAI, which are ZImage, a fast text-to-image generator, and SAM3D. So ZImage is an extremely fast, nimble image generator, which in only a couple of billion parameters manages to do a very good job of generating those images. You can try it out on their website, but it is also exposed as an endpoint by FelAI. And FelAI is basically a website where you can access all sorts of generative models through a unified API after having put, of course, some credits on there. So I was taking a look at how the code actually works and exploring their source code a little bit and was poking around, and I was kind of going through all of this until at some point I found this utilities folder, and there I found a promising entry point, the SAM3D Stream API class. So I opened that up, and basically this is relatively simple in the sense that what this thing is doing is it sets up an HTTP client, and then basically there are two main commands implemented, which is generating an image from text, because SAM3D is a 3D generation model, which starts from an image. You need to generate the image or the 2D image first. So you take the user prompt, you augment that with a little bit of spice to say I want a plain white background, a view from diagonally above, and that will help the 3D generation. In the next step, you give the prompt, image size, inference steps, how many images you want, safety check, and so on, and the output format. So after doing this, you basically end up with an image. Now you see that the URL, which is utilized here, there are basically two endpoints, one being the ZImage endpoint on FelAI, and the other one being Rehan's SAM3D stream endpoint, which is the SAM3D adaptation, which allows you to receive streamed output back so that you can see the 3D object generating step by step. So that's basically what the other endpoint does in here, which is stream using this SAM3D model. And likewise, also for that, we build up a request body. They give it an image and the prompt again. Not sure why. Maybe SAM3D does take an optional text prompt. We do not give it point prompts or box prompts. Probably they are not necessary here. That's probably to segment out specific parts of an image. And then we want to have geometry every couple of steps. And then basically we fire off an HTTP request again, and then we wait for events to come in. And these are SSE events. So I guess those are stream SAM events. Basically, those probably generate steps or represent steps in the generation process. So this is some sort of JSON that gets sent back. So if we check if a line starts with data, we check if there is JSON in there, and then we check stages. So there are geometry steps and appearance steps. Interestingly, once we do have voxels to process, so to show them in the game, we or the plugin calls this process, or the mod calls this process as the event thing. So this is where the main parsing of those events happens. So we check further. There is basically a geometry phase and appearance phase. We see that there is like bounds which are passed to basically know the bounding box of the object that we're generating. And then there is this voxel data that apparently has to be decoded. And that's done by this voxel decoder thing. And this plugin has already done the hard work for us. We could look at the documentation where we see that the streaming endpoint returns voxels in a base64 encoded format, and each voxel is represented by 6 bytes, meaning or 1 for the normalized X value, Y value, Z value, and then 3 bytes for the RGB color value. So that's what's being done here. And I guess somewhere what this thing is probably doing is mapping the received, or it's first on normalizing the bounding box that we have in integer coordinates in Minecraft, and then probably it's also trying to map, I guess, the colors that we have to material blocks in Minecraft, because we need to convert the RGB to something that matches in the game. Yeah, SAM3D uses Z up, Minecraft uses Y up, so it's doing a bit of conversion here. But then, yeah, we have these colors that we have, and indeed there needs to be some mapping. So I guess at some point it will map this to probably wool or something like that, where the object can actually be rendered. Okay, yeah, that's it, right? So this thing maps the RGB colors to the closest matching Minecraft blocks, and here we go. So, right, we have concrete blocks, stone blocks, wood blocks, so a lot of colors that we can resolve to, or that the original colors can get mapped to find a good matching between the original color and a block color in Minecraft. Okay. Now, I was looking at all of this, and typically what you see with these kinds of fabric mods is that you end up with like a whole bunch of Java code, which does allow you to do very neat things. Like with this mod, you can move the object around, you get a live preview. But I wanted to have a quick implementation to see this working for myself without going through all the fabric trouble. And I've been working for a long time now on a plugin for Paper or Spygot servers that allows you to write Python code. And in the past couple of days, as it turns out, I have been kind of rewriting this whole thing to work on the Graal VM instead of Jython in order to be more Python 3 or to be Python 3 compatible. On Mac, which I'm using today, this is still extremely buggy. It works, but there are still crashes in there. But in any case, the basic stuff does work. I had a bit of help from ChatGPT to help me convert or construct a Python version of this 3D generative idea after giving it my plugin docs. And this is basically the Python plugin that I ended up with, which is in this case a single Python script. So we have the same two endpoints in here. I've purchased a couple of credits on FelAI, and we are working with a very limited palette in this case, only with the concrete blocks. The others I could, but I didn't put them in there. I didn't want to make the file too large, and honestly I was too lazy. I just wanted to see if I can make this work quickly. The rest is basically a bunch of utility functions to check whether things are numbers and so on, and to store a provided API key, which you need to give as a user of this thing. Then basically a function to make HTTP requests using standard Python libs and get a JSON reply back. So I'm not using something like requests here because it's still pretty messy to load in external libraries in this Graal VM because a Python interpreter is living inside of the JVM. So I'm just doing the standard libs. Then we have the same kind of function that generates an image with ZImage, and we have something similar for firing off a request to SAM3. Same as the core of the original. We could have used other image gen endpoints, but I kept those the same for now. And then we have similar callbacks to basically say, well, every time we receive an SSE event, we parse out the JSON and then we process that event. There is a processor here that does very much the same thing as what was being done in the original Java code. So we check if it's a geometry appearance event, and then in both cases we have a similar base64 decode step, fetching out the XYZ positions and the color positions, just as we did before. So now we can see this in action. What I think is pretty cool about this is that all of this fits now in a small single Python file, about 680 lines large, so not so large. And if we switch to the game client, I've already been playing a little bit around with this. But now if you go to the Minecraft site and we make sure that we look at a kind of suitable position at the ground level, and then we can say, okay, let's generate something. I generated a pink cute cat earlier, so let's switch to a cute black dog. And let's see what happens. So the first step is a generation of the 2D image. That always goes very quickly. And then we pass that to SAM3D to convert that into geometry. And then in a couple of steps, we see it first generates the mesh or the geometry, and then it fills in the colors or the appearance where it kind of blackens up the doggy in our case. And after just a couple of seconds, our generation is done and we have our doggy in Minecraft. Pretty cool.